Hello there everybody. For some time now I've been wanting to find some way of examining the cutting edges of these tiny little tools I'm using. That's a 1mm PCB cutter, and this is a 60-degree angle V-bit. So to get an idea of how worn these are, I've been looking at ways of examining the cutting edges on these. So what I've thought of doing is I've bought one of these things. So I'm going to show you the capabilities, the pros and the cons of this device, and the fact that it's not exactly working out very well looking at these tiny little cutting tools. And I've decided to make a new mount for this rather than this thing here, which as you move it, the thing moves from side to side, and at high magnifications the bit just disappears off the side of the screen. Because it moves slightly sideways as you move it. You might be able to see that there. And at a magnification of 500, the setting just disappears off the screen, the image disappears off the screen. So I happen to have a couple of these spare from a previous project. So I've decided to implement them in my own rig, using them as a vertical axis and making a mounting plate. If you can imagine two of these, and a screw thread with a handle on the top to wind it up and down. So I'm going to be showing you how I designed and made this gadget, and hopefully show that it's a little bit better than this plastic device that I bought. I mean, it wasn't very expensive for the price. It's quite good, but it just doesn't match the mechanics of this. Just don't match the amplification you can get, the magnification you can get with this microscope on top. So I'm going to show you the actual design assembly drawings and the individual drawings prior to the construction of this gadget. Oh, I forgot to mention, I also bought this, which is a ring flash, which can mount on the very camera that this is being recorded on, and this is also going to be incorporated in the design, so I can use this and the camera in the same gadget. So in effect it's going to be a dual purpose mount for the microscope and the camera that's recording this video. Right, I've got this set up with a small printed circuit board down here, and I've got the mount as high as possible and wound up as high as possible, and at the lowest magnification that we can get. That's really right down to the bottom of its range. Now that's not too bad for that. I think that's quite good. Showing the tracks here, just little solder blobs, and this is showing the cut between the tracks with my engraving tool. And that's quite adequate for my purposes, showing me PCB efforts for milling a PCB. So that's with, I think, the lowest magnification there, which is ideal for what I want. This piece of software came with the device. It's called AMCAP, It doesn't do any measurement, you can't measure anything, but you can certainly see quite well what's on the printed circuit. Now of course, if we move down and wind up the magnification, come back and focus. It's a little bit more magnified, and down again. We'll go right down to the bottom, and we'll turn this down to the bottom of its travel also, right down, and then wind this up. We can't get it into focus. We seem to be beyond the limit of its range here, can't quite get it into focus, so let's wind it up a bit. Try again. There we are. That seems to be in focus. Now you will notice that as I turn this knob here, it does shift around. This thing does tweak from side to side. And also this pillar is not terribly stable. Probably could be made so, given there's some attention to this bottom fixing here, maybe it could be made so. But it does seem a bit imprecise, but you can get good results. So that's that. I have noticed one thing. You see that black patch in the middle? That's not a fault on my circuit board, it's a shadow, and the shadow is cast by the lens holder in the microscope. I'll be able to show you this. If I pick the microscope out of the holder and raise it up, the shadow disappears. Put it back in, and there's a shadow cast. There's like a cone of darkness. What a wonderful name for a movie. Cast on the focal plane, and of course you're trying to see an image in the dark, and if I pan up to the screen, that's the result. Now what was that? I think an email has come through. I'll try and focus it up as best I can. You see the problem with the mechanics. And go back, and there's still a cone of darkness. It's a small problem, but just thought I'd point that out. You may have noticed that I've been using the gadget without this cap. Not only can you take the cap off the end, but you can also take that off, which allows the lens part to poke out through there, and you can get down really close to an object. Also, when this arrived, this part here was loose and was really screwed right out like that. For some reason, I don't know why. In fact, you can take this out. I'm not sure what that is, maybe some sort of filter, but of course the actual graphics matrix is in there, right in there, and we've got a lens in here, and maybe that's a filter, or maybe it's the lens itself. I think I can see the lens behind that square piece in there, so the lens will be in there, and that is the part that moves in and out. So for some reason when it arrived, this was screwed halfway out. Anyway, I decided to screw it all the way back as far as it would go and tighten it up. But even with it screwed right in, when you're fully extended like that, it is still too far away to allow light from the LEDs to impinge on the object without making a shadow. So what may be able to cure that is if that is taken out and a piece shaved off the end of the thread. Maybe, I mean, there's plenty of it. Obviously can't take any off that end without being in there, but maybe something can be done with this to allow light to go past. But anyway, it's a minor problem, and I don't think I'm inclined to do anything with it unless I'm prepared to accept the fact that I'll ruin it. But the one thing I did do, as I mentioned, I screwed this right in. It minimised the shadow problem. Now, I've looked at the user instructions that came on the disc with it, and in fact there's no mention of what this is for, aside from keeping the dust out of it. Shove that on and put that back. That obviously keeps the dust out, but I think for use you really just have to take it off, which is what I've done. So I'm going to leave that off for the time being for this demonstration. Now that completes the demo of the hardware and software for this microscope. So let's have a look at the drawings I've come up with for a new mount for the microscope. And now that you've got all those lodged in your brain, let's machine them. Right, we've got this piece of 6mm plate fixed on the table, 6082 grade, and the first thing we're going to mill out are a couple of test holes and a test slot, plus this test piece to see if it fits into my test slot properly, and that will verify the slots in all the other pieces. If of course the slot is not the right size, we'll adjust things until it is. Right, and these slots I've milled in, this is going to be the back plate, the device, and these slots are for the side plates to fit into accurately. And this is a piece I've cut out over here of the same material, just to test that it fits, and they do fit nicely into the slots. So that's the back plate slots done, and I'm going to cut the bottom plate and the top plate slots now. Good. That's it cut out. Left tabs in, cut them through and the baseboard comes out. Right, has to be a bit more machining on the back and a polish and some varnish, and that's that one. And there is the baseboard with several coats of varnish and sanding and varnish and sanding and varnish and sanding a number of times, actually 7 times to be accurate. 4 little feet on, and that looks quite nice and feels wonderful. I suppose I could have used a larger diameter milling cutter, but it just happened to be in the machine there at the time. And it looks as though it's doing a reasonable job, and it won't take long. And there it is, milled to the thickness I need, which is 16, and it's measured at 16.067. This is just a little trick I use to center the tool on the material. Make a life-size cutout of the part and then just center the tool on the reference point on the part. In this case it's the center of the part. So there it is set up. So I can just remove that and the tool is centered. Okay, let's see if the metal fits. Oh, that'll do. It's going to be glued in, so that'll be fine. Right, okay, we've got a piece of plastic clamped down, and this is the template to show where the centre is. I'll line up with the centre there. Now, milling plastic, you have to be very careful that the cuttings don't melt onto the tool tip, and that's spelled disaster. just over half the way through now. Well, we're on the last lap now. Okay, we've got the pocket milled in, we've got this circle milled out. Now I'm going to mill all the two pieces. Did anyone spot the deliberate mistake? I forgot to put some fixing screws in here. Otherwise, when it broke through, these parts could swivel all over the place on these points here. And we'll start again. Now you might have been wondering what the hexagonal recess was for. Well, it was for this brass insert, which goes into there. Now I haven't bothered to show you me turning this. I think pretty much everybody knows what turning looks like. So that goes in there, and that's going to be the top fixing point for this holder. That is of course a 1/4 Whitworth thread. Now I do not have a knurling tool, but my friend Colin does. So I dodged over to his place with my piece of aluminium bar, and we performed the knurling on his trusty Myford. Incidentally, these few shots taken in Colin's workshop were taken on his iPad.
Could have done this at a higher speed. So anyway, I couldn't do the nail at a slow speed. But I don't get really finished it, it's quite... Oh, that isn't on centre height. Oh. try it.
Not to get a view of it. Might be a good idea to put a pencil mark at about 60 millimeters long.
Good idea. But we need to use the pencil. I think that's a bit too slow. So it's better to start off too slow and too fast. Cutting the shavings off there.
Yeah.
I think that's it. About as far as it goes.
Yes. Okay, okie dokie, lovely jubbly.
That'll give you plenty of grip. Oh, not half.
Oh, aye. Great. Right. You know, unclamp it from there. Oh, was that your knuckles cracking?
Yeah. Sorry, I've got 9 more. Of course, if you want to look at it closely, no better, is it?
No. You can see it better with the eyes.
Yeah, I'm not in focus. Just focusing on this rather.
It just needs washing out and that'll look.
Yeah.
And here are all the parts laid out on the drawing board. And if you want to see how we get from this to this, have a look at the assembly video. Well, I hope you enjoyed all that, and if you want to see how it all goes together and some of the results it can come up with, just have a look at the assembly video. It should be knocking about on YouTube somewhere.